Hello friends, you are watching ERUDIRE PLUS, the professional CAD/CAM solution provider. Let's get started.
Hello friends, today we'll show sloshing effect of oil inside an oil tanker. Actually, this sloshing effect is very important in oil and gas field. It is very dangerous. Sometimes it can produce some kind of accidents also. So it is very important to reduce the peak effects or torques inside this oil tanker. Now, how this sloshing effect occurs inside this tanker, I'll explain this one. When the tanker is moving with some non-uniform acceleration or something else, sometimes it may stop suddenly by applying brakes. In that case, what will happen? The oil inside this tanker will be having some abnormal behavior, abnormal movement of this oil inside this tanker. It's called actually sloshing effect. And because of this sloshing effect, the oil actually is exerting some amount of pressure and torque inside this tank. So because of that, sometimes it may produce some kind of accidents. So to reduce these accidents, some kind of baffles are provided to reduce the torque and force, etc. In this analysis, what we'll do is initially we'll perform one analysis without using any kind of baffles, and we'll see the sloshing effect inside. Inside this sloshing effect, we'll see the force generated inside, by the same time torque and also turbulent energy. Next to that, we'll see some different design. That means by applying some kind of baffles, we'll see what are the effects, how the torque and also force etc. is reduced or increased. That can be checked. And finally, from these two different analyses, we'll compare the results and select the better design. Okay, so without wasting time, let us start our analysis. This is the model without any baffles. Actually, we have to analyze this one using free surface technique. It is a new technique which is implemented in SolidWorks from 2018 onwards. Actually, in SolidWorks, we cannot mix heterogeneous mixture normally. So for using oil and air, we have to use some different techniques known as free surface technique. For understanding this geometry of this tank, we can cut it from front plane and see the geometry. You can see the top part is filled up with air and bottom part is actually filled up with oil, right? For starting this analysis, we have to create this flow simulation environment, and for initiation of this flow simulation, we have to initiate the environment with flow simulation itself. So we can start with wizard, and the environment is created. Default name of the project we are keeping as project 2. Next, we are considering the system as SI. As usual, we'll take temperature as degree centigrade, though it is not required. Next, it will be an internal analysis, and in this case it is a time dependent one. It is a transient analysis, so we have to depend on time. We are considering time equal to 10 seconds, and we'll see the results after 0.01 seconds. Definitely gravity is involved, and direction of gravity will be y. So along y, value of g will be minus 9.81 meter per second square, and along z it will be 0. It is a free surface technique as we are mixing oil and air. Next, gases will be air definitely, and oil in this case we'll consider as propane. Both the things are actually of different stages. We are mixing oil and air. It is a heterogeneous mixture, that's why we are using free surface technique. Next, default wall thermal conditions and roughness we are considering. Thermodynamic parameters, it is not that much of important in this case. Yet let's take the temperature equal 20 degrees centigrade, and initial concentration of inside this container, it will be air. Let us finish this. You can see the computational domain. Actually, it is considering the top part which is filled up with air only. The bottom part it is not considering. So what we will do is we will enlarge this computational domain. Let us edit this part and make the domain little bit bigger, because we want to include propane also inside this domain. Domain is ready. You can check. Now you can hide this domain. Okay. Now first of all, we have to define that solid part as oil. So that can be done from conditions, initial condition, and we have to define the solid part. So we are selecting that solid part. The name of that solid part we have kept as indent 1, selected, and that to be disabled as solid component, and we have to consider this one as propane liquid. We are not changing any volume Vx, Vy, Vz. We are not changing because initially when the tanker is at rest, there is no relative motion between this oil and the main vehicle. Okay, grain check, it is done. And here in this case we don't require that much of changes in the boundary conditions. One thing we have to do, as the car will be moving with some uniform acceleration or like varying velocities, etc., whatever it may be, that to be defined. So that can be defined from the general setting itself. We could do it before also. While providing the acceleration due to gravity, you can do these things. Acceleration due to gravity is acting downwards. So here in this case, let us think that car is moving in the x direction. So we have to change the x component with some dependency. The vehicle may move with constant acceleration also, but here in this case we'll see something else. We have to see the results in a better way. We'll change the acceleration in a different way. Let us define the movement of the tanker using this graph. At time 0, the acceleration of the tanker was 0. When time equals to 2 seconds, let the acceleration will be 5 meter per second square. When the time equal to 3 seconds, let it is moving with same acceleration 5 meter per second square. And on the 4th second, let it is coming down to 0. 4th second, let the value be 0 meter per second square. And as we are considering this one as for 10 seconds, it will move up to 10 seconds. Now 4 seconds onwards, it will not have any kind of movement. Its value will be 0. We can see the curve. Like initially, it will have 0 acceleration. After 2 seconds, it will be moving with 5 meter per second square acceleration. Then up to 3 seconds, it will move with the same acceleration. And 3 to 4 seconds, it will come down to 0. And from 4 to 10 seconds, again it will continue with the same value. Is defined. Apply. Okay. Now all the setup is ready. Next one, we have to set some goals. To see the sloshing effect, we have to determine some goals. All the goals will be as global goals. Goals. Insert global goal. We want to see a lot of things like velocity, dynamic pressure, etc. Let us say average dynamic pressure, average velocity in the x direction. At the same time, we want to see average turbulent energy and also torque, that is the pitching effect. We want to see the torque in y direction. Go ahead and check. Next one, we can see the mesh. To have better results, we can have a better mesh. Let us see the global mesh. And go for manual one, and let's see display of refinement. It is not that much of refined. It is refined up to level 1. We can make it little bit more to have better refinement. Let us go for further one stage more refinement. This is okay. Done. Now we have defined 4 different goals: dynamic pressure, average velocity, average turbulent energy, and you can say that torque. Another thing we can find out, force also we can find out. Goals. Insert force exerted on the surface walls. Grain check. So these are the different goals we have defined. And before starting this one, we have to select calculation control option, saving, and we are changing from here the periodic options, and we have to select from here immiscible air and immiscible propane. By the same time, we want to know volume fraction of air and volume fraction of propane. Okay, done. Next one, we can run this. New calculations will start. Iterations have already started. Mesh preparation is going on. let the iterations move. Whenever it is finished, we'll see the results and go for further analysis with Baffles. And the solver is finished. We can see the results. Like average dynamic pressure is 53.53 Pascal and average turbulent energy is 0.268 joules per kg. Average velocity in the x direction is 0.002 meter per second and force is 9.06 kilonewton. These are the results obtained from solver window. We cannot understand anything about the behavior of this sloshing effect with this data. It will be better to see the visual effects. Let us see the visual effects to understand the behavior of sloshing effects. Let us close it. Let us see the front view. And initially you have to start transient explorer to be on. That immiscible fraction of propane and air to be seen. That can be checked from the cut plots. Insert cut plot. From the front plane, we want to see immiscible propane. That means we want to see the dynamics of propane and air mixture. Up to 10 seconds you can see the behavior of propane inside this tanker. The top part is filled up with air and the down part is filled up with propane. Because of this sloshing effect, actually some kind of force is exerted on the tanks and there is a possibility to have some kind of accidents because of these sloshing effects. Let us clear and hide this part. Next one, we want to see some other things like volume fraction and mass fraction of this propane and air. Cut plot 1, clear and hide. Next one, we want to see some other cut plots. Insert. Volume fraction of propane. Let us see. Initially the red part is filled up with propane and the top part, the blue part is filled up with air. And in between different layers are there, that is mixed fractions of air and propane. Let us clear and hide this part. Next one, we want to see something else like cut plot 2, clear and hide. And next cut plot, we want to see something else. Let us see velocity along x direction. Okay, let us clear and hide this part. Next one, we want to see our goal plots. Insert goal plot and we want to see all the things. Selected, show. These things we have already seen in our solver window. You can see all these results in the form of history, also in the form of graphs. Like you can see here, the most important part is your torque. Torque value was very high. Torque is actually causing the pitching effect. It is near about 80,000. It is very high, that to be reduced, right? In the upper side it is 80,000 and downside it is approximately in the range of 35,000. So with the design of Baffles, we have to minimize this. Next we will see the analysis with a different design with Baffles. Let us close these things. And also the transient explorer should be also off. Next one, we will have to go for different analysis with Baffles, right? So here itself we can model that Baffle. For that, what we will do is we can make a clone of this one and modify the design, and renaming is this project as project 3. Everything is copied. Now what we will do is in this analysis we will put some kind of Baffles, and this new project name is project 3. So we have to go to the geometry and make the baffles. Let us select the front plane and let us start sketching baffles. In this case, we are not considering any kind of complex baffles. Just to see the behavior and the difference between without baffles and baffles, we are making some general types of baffles. Okay, so we are making some lines. Let us provide dimension to this one as 2000 millimeter. You can check. Next to that, we can make some kind of similar type of things on both the sides with offset entities. Select that line. With offset entity, we can make similar type of things at specific distance away. Suppose you are making the same lines 1000 millimeter away. Done. Green check. Select again. We will repeat these things. Select offset entity. We can make it bi-direction also by selecting here. It can be done. Select again. Offset entities will make in the other direction. Again, same thing. Select offset entities, other direction. Select offset entities in the other direction. So we have made enough numbers of baffles at 1000 millimeter away. Next to that, we want to provide some kind of thickness to these lines. Very fine baffles we want to make. So exit from the sketch, and what we'll do is we can select a different sectional view of this one. Let us cut it from different plane, like right plane. Green check. Next to that, we have to provide some thickness to these baffles. Select all these lines and we have to provide some thickness from features, extrude boss base. We are not merging these results. Instead of blind, we have to make up to the body. This side. Can change the direction by changing the arrow direction, and in the other direction also we can do it. In the second direction, same thing we can do. Instead of blind, we can make it up to the body. Let us select this side. Green check. Okay, it's done. Baffles are made. We can see the complete view of the model and cut it from some other plane. We're cutting from front plane. So these are the baffles. Now with this modified design of baffles, we'll see the sloshing effect and see the different results like torque, turbulent energy, etc., and compare these results. And finally, after comparison, we will find out which design is better one to reduce the sloshing effect. Okay, done. So let us save these things with the name of tank with baffles. Save it. Next to that, we have to go for analysis. This is project number 3, and all things we have copied. That means we are not changing any parameter. We are not changing any input variable. All the things will be same. Now with the different design, we can run it. Let us run this. We are starting a new calculation. Mesh refining is going on. When the iterations are over, we'll see the results and compare this one with our previous analysis. The solver is finished. You can see the results. Like the most important part is the torque. Now we can see the torque is very less compared to the previous results. It is now only in the minus direction is 615.62 Newton meter. Better to see these results from the cut plots and compare. Okay, let us close these things. We will see the results from the cut plots. Let us close this. We will see the results from front plane. And for starting this one, we have to select that transient explorer to be on. Transient explorer is on. We can drag it down and make this tank a little bit bigger for better understanding of the sloshing effect. Next one, from the cut plots, we'll see cut plots, insert cut plots, and we want to see immiscible propane. As we saw from the first analysis also, same thing we'll see. Let us play these things. It is visible that sloshing effect is little bit minimized. Lot of minimization is there. We can see the sloshing effect is not that much. So with this baffle design, we reduce the sloshing effect. Means we can see the pitching effect. Let's clear and hide this part, and we'll see some other things. Clear and hide, insert. Instead of immiscible propane, we want to see something else like volume fraction of propane. We want to see. Let us play. In this case also, you can see it is reduced little bit compared to previous results. Okay, just close these things, and it's better to compare all these results and select the better design. Clear and hide this part. Cut plot 5. Clear and hide, and even the transient explorer also we can make it off. Now better to compare all these results. That can be done from the Excel, or we can get it from the results here itself. Compare the results. For comparison, we are having a lot of things. We'll compare project 2 and project 3, and we are bothered about goal plots, right? Now I want to see the goal plots of this analysis. Goal plots, insert goal plots, and we want to see all the results. Let us see. These are the results we have already seen in our solve window. We can see these things from the history in the form of graph also, right? You can see here the torque value is actually minimized. It is in the range of -8,000 only, and in the upper region it is approximately 2,500 only, right? And all these results we can compare side by side. Both the analysis results we can compare side by side. Let us go for comparison. Results, compare, and we want to compare both the results. Default project number 2 and project number 3. We have to compare goal plot 1 and goal plot 2. Let's compare. It is done. Now see the comparison. Here is the comparison in the form of data. Better to compare these things in the form of graph. So we'll see the history from the summary, and we can compare these results, right? The blue one is the project 3, that is the latest project, the Baffles, and project 2 is the initial project without Baffles. So dynamic pressure is very high in the case of project 3, that is project with Baffles. Maximum pressure is in the range of 500 Pascal, and in case of initial simulation, the maximum pressure was in the range of 357 Pascal. Similarly, turbulent energy, you can see turbulent energy in the case of second one is high, first one is less. Mainly for analyzing these things, we have to depend on that pitching effect, that is torque. Torque is very high in case of first one, that is project number 2 without Baffles. The torque value was in the range of, we can see here it is in the range of 77,448 Newton meter in the upper region, and down region it was very high also. It was in the range of 32,832. But in case of the Baffles, the torque value was minimized. You can see here the maximum value is in the range of 7,500 only, right? You can see the force results also. That means in case of without Baffles, the force exerted on the side was more compared to the force exerted with Baffles. Okay, so these are the results. Next to that, we can go for some kind of parametric study and optimization with Baffles. Okay, that type of analysis will be done in a different analysis, in a different video. Okay, so this is all about our today's video regarding sloshing effect inside an oil tanker. This analysis was done with Baffles and without Baffles, and from this comparison of different data obtained from this analysis, we found that the design with the Baffles is better one, in which we can minimize the torque, that means pitching effect is less in the second design, where we designed this tanker with Baffles. Okay, If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.